Alexa, tell me a joke.
What do you call a sleepy woodsman? A slumberjack.
Alexa, what's the weather gonna be like tomorrow?
Right now, it's 37 degrees Fahrenheit with partly cloudy skies. Tonight's forecast has mostly clear skies with a low of 29 degrees. Enjoy your evening.
So today we're going to be building an Alexa-enabled smart clock. Right, JC?
Yep.
Let's go! So today we're going to go over how we built this custom smart clock with Alexa AI built in. This is a pretty cool project that uses the Raspberry Pi and something that kids can also help out with. They can help with a little bit of the coding, understand how to install modules and use the Raspberry Pi, and they also get to use LEGOs, as in this case where we used LEGOs to build the case around the smart clock. So this isn't going to be an in-depth how-to video because basically pretty much all the steps have been YouTubed before. So what we're going to do instead is basically highlight our steps and provide links to other helpful YouTube videos and other links down in the description below. So be sure to check that out. So to start things off with the install, first of all, we're going to need a Raspberry Pi. This is a Raspberry Pi 3B Plus. We've also got the SD card plugged inside it. We'll also need the power adapter for the Raspberry Pi. We'll also need a 3.5-inch LCD screen. This is a screen that we've had from a previous project, so we're just reusing this screen that we've had, but you can find them on Amazon or eBay. It comes with a case, at least this one did. We're also going to be using an HDMI cable to plug into the secondary monitor. We've got a USB keyboard, and, well, there's the secondary monitor. It's a TV, actually. Like I said, we've got the USB keyboard that we're using because you're going to need that to code some scripts to get things installed and running. We've got a mouse, and we've also got some secondary speakers, some speakers that we've got from a previous project that we just have. And we're also using a USB microphone that we obtained from a previous Raspberry Pi computer kit. So basically everything here we've already had laying around the house. We haven't had to purchase anything. But obviously, if you don't have any of these things and if you want to build this project, then you might have to go out and buy something. But the good news is most of these things are readily available on Amazon or eBay, and the cost isn't too crazy expensive. Okay, so the first thing we got to do is we got to take the SD card, plug it into our secondary computer. You'll need another computer for this to kind of format the SD card and install Raspbian. Raspbian is the Raspberry Pi OS operating system. We use the SD card formatter and etcher, which are pretty common and pretty popular apps to format the card and also install the operating system. Okay, so that's kind of the first step. Next thing we need to do is plug it into the Raspberry Pi and configure this 3.5-inch LCD screen. It plugs right into the GPIO pins, in this particular case anyways. And what we need to do is configure this screen so that it all displays on the screen. So what you need to do is go in and attach the HDMI cable to the Raspberry Pi once you get the screen attached to the Pi. So when you first power on the Pi with this 3.5-inch screen, you kind of get this white blank screen on the 3.5-inch screen. But then when you plug in the HDMI to the secondary monitor, everything kind of boots up as normal on this secondary monitor. And what you have to do is you basically, if this is the first time that you've booted up the Pi since you've installed Raspbian, you have to do some early install steps such as setting up the Wi-Fi and your location and things like that. But once that's done, then you can go into these steps to configure the 3.5-inch screen. Here's the site that I found pretty useful for setting up the 3.5-inch LCD screen. There's just a little bit of code here at the bottom of this website that you need to put into terminal in the Raspberry Pi, which will basically activate and install LCD show, and it'll basically activate the 3.5-inch screen. Once you run this code, basically the secondary monitor that you have, in this case my TV, will turn off, or at least it'll go to a sort of a blank screen that just shows code, and then your 3.5-inch screen will start to display the correct information. It'll show Raspbian, the desktop interface for Raspbian. And then after that, what we did was, we got the kids involved and they got to build the Lego case. In this case, what we had is an enclosure for the Raspberry Pi, but we wanted to build a Lego case around that so that it sort of hid the wires a little bit and made it a little bit bigger, gave it a little bit larger profile. And once we were done with that, we had the face of this Lego case, and I took a little handheld hacksaw and carved around pieces of it so it fit with the Raspberry Pi case, so it kind of gave it a nice enclosure. I also cut out a few notches on the bottom so that the wires were able to freely come out the back of the case, so that the wires weren't exposed in the front, or that the case wasn't sitting on any wires, sort of making it lopsided. So this is sort of the finished product. Using the hacksaw, we sort of carved out pieces of the face of the Lego case so that we could see the LCD screen, and also that the microphone would be displayed. So now what we need to do is install the software for displaying our smart clock display. And basically what we're using here is Magic Mirror, and this is code that's open source and available for the Raspberry Pi. It's basically intended to be used as a smart mirror, but in this case we're not really adding the mirror. We're just going to use this as a smart clock display. But we're going to go in a similar fashion and install Magic Mirror here. Here's the website. The code is pretty easy to follow to install, and it doesn't take too long, just a couple minutes for everything to install, and you should have Magic Mirror on the Raspberry Pi. And then once it's done, it'll automatically jump over and show the website display of what it would look like. However, since this is a 3.5-inch screen that we're displaying it all on, things are possibly and most likely going to be compressed. As you can see here, things overlap. So what we need to do next is go in and configure the Magic Mirror so that things are displayed the way that we want them to, and they're not overlapping, that kind of thing. And then after that, we can go into the config file for the complements. This is one of the cool and unique ways that you can customize your smart clock, is to have custom complements and things like that. And so we're going to go in here and change the complements, especially to make it a little bit more kid-friendly complements that kids can edit and make for themselves, because after all, this is going to be a smart clock display that my daughter's going to use in her bedroom. But once that's done, you should be able to reboot your Magic Mirror, and now you'll be able to see things aren't as overlapping. It could be possibly trial and error in this case, where you can kind of go back and forth to kind of make sure things are displayed just the way that you want them. And this is exactly how we want our display, with sort of the date and the time on top, and then complements just beneath that. And that's really all that we plan to show, at least in text, on this 3.5-inch display. And we'll let Alexa take care of the rest. And now that we have the clock displayed the way we want it through Magic Mirror, now it's time to add the Alexa module. In this case, we're going to be using the Awesome Alexa module that's available through the Magic Mirror modules page. And we used a couple of handy other instructions according to this, such as How to Geek, and a couple other YouTube videos that we've linked below to kind of help navigate through this process. It's pretty easy. For the most part, you can use just the installation guide that's through the Magic Mirror Awesome Alexa module install. But we did notice a couple places where it was, we got hung up a little bit. And so what we found that helped us anyways was, after we got past a certain point and got the module installed, we had to reboot the computer, reboot the Raspberry Pi before going through the setting up the Alexa module through Amazon. So it's kind of a two-step, well, at least a two-step process, where you've got to first install the module and then set up a developer account through Amazon to use the Amazon Alexa technology. But once that was complete, it was pretty easy. And then you basically go back into the Magic Mirror and you can start talking to it, and you have Alexa enabled, and she'll talk back and help you out. Like I said, my daughter really wanted this for her bedroom. Yeah, this one in particular sort of looks like a box of nerds, almost like candy, almost, with the color combination here. But she really likes it. She likes that she's able to customize some of the complements and the display a little bit.
Alexa, set a timer for 5 minutes.
5 minutes, starting now.
Alexa, set an alarm clock for 7 a.m. tomorrow.
Alarm set for 7 a.m. tomorrow.
Hopefully you enjoyed the video, found it interesting, and found it inspirational for whatever Raspberry Pi project that you might be thinking of doing. I'd be happy to hear your comments and feedback, so please let us know below what you think. Hope you like it. All right, thanks everybody. Bye-bye.